How do I express infinite solutions for a dependent system using a parameter? Imagine solving a puzzle where no matter how many pieces you add or move around, the picture stays the same. That's what happens when a system of equations has infinite solutions. When the equations are dependent, they describe the same geometric object, like the same line or plane, which means there are endless solutions. To show all these solutions clearly, we use a parameter, which is just a variable that can take any real number. This helps us write every solution in terms of that one variable. First, you need to identify if your system is dependent. When you simplify the equations, you might find one equation reduces to something like 0 equals 0. That's a sign the equations are dependent and the system has infinite solutions. Next, pick one variable to be your parameter. Usually, you choose the variable that is free or not fixed by the equations. Let's call this parameter t. Since t can be any real number, it represents all possible solutions along the line or surface. Now solve the remaining equations for the other variables in terms of t. For example, if you have three variables, say x, y, and z, and you decide to set z is equal to t, then you substitute this into your equations. Solve for x and y in terms of t. Once you do that, you can write the entire solution as a set of equations like x is equal to 2 plus t, y is equal to 3 to t, and z is equal to t. This shows that for every value of t, you get a different solution, and all solutions are captured in this parametric form. This approach makes it easy to understand the whole set of solutions. The parameter t acts like a dial you can turn to get any point along the line or surface described by the system. It turns what might seem like a complicated set of solutions into a simple, clear formula. For example, if you have a system of three equations with three variables, and after simplifying, only two equations remain as independent, then one variable is free. Setting that free variable equal to t, you solve for the other two variables in terms of t. The result is a parametric description that covers all solutions. Using a parameter to express infinite solutions helps you visualize the solution space as a line, curve, or plane. It also makes it easier to analyze and understand how the solutions relate to each other. Remember, the key steps are to identify the dependent system, pick a free variable as your parameter, and then write all other variables in terms of that parameter. This way, you turn a potentially overwhelming set of solutions into a neat, understandable formula that shows all possible solutions at once.